Now let's talk about proportions. So proportion is an equation stating that two ratios are equivalent. And in order to solve a proportion, we may use something called cross multiply. And you've probably familiar with this technique already, but we're gonna review it because it's gonna be necessary for a lot of the problems we're gonna be doing moving on. Now here's the general formula. So if you have a ratio A to B and it's equal to another ratio C to D, under the special condition, we have a little disclaimer that B and D are not equal to 0. So again, the denominators cannot equal 0. If this is true, then we have this statement: A multiplied by B is going to equal B multiplied by C. And that's where you get that that's where you get that name cross multiplication, because you can technically cross multiply A times D and then cross multiply B times C, and you get this new equation. So let's test it out with a couple of examples, beginning with this one, example 5. And here we want to solve for x. So let's apply this new technique of cross multiplication. So here we're going to do 10 times 10. So we got 10 multiplied by 10, and that's going to equal this other part, 8 multiplied by x. So 8 multiplied by x. And here we're trying to solve for x, so let's split the equation so we can identify the left hand side and the right hand side. So on the left hand side, I don't have any variables, so I can combine these. 10 times 10 is 100. For the right hand side, I can't combine them, but I can put them next to each other. This is also referred to as juxtaposition, where the terms are not necessarily getting mixed together, but they're next to each other. So here I want to isolate x. I want to isolate x, so I have to do the inverse operation of whatever's happening to x. So here it's getting multiplied by an 8. The inverse of multiplication is division, so let's divide this by 8. And whatever we do to one side, we do it to the other. So here we're going to divide 100 by 8. So 8 divided by 8, that's going to give us 1. So 1 times x. And here, here we're going to see a little problem, or we're going to identify this as a problem for like 3 seconds, because we're going to realize that 8 does not divide 100. 8 doesn't go evenly into 100. So let's just leave it as 100 over 8 for now. And then 1 times x, well, that's just x. So we have this x is equal to 100 over 8. Now in our previous unit, I would have told you to get the decimal and then get the percentage, and we were good with that. But again, here we're trying to compare things. So we're actually going to reduce this. One way to reduce this is by getting the greatest common factor. So here, let's kind of move this right here. So I know that the greatest common factor here is going to be 4. So we're going to divide the numerator by 4, and we're going to divide the denominator by 4. And if you're very good with your multiplication tables, it's going to be very, very easy to spot the greatest common factor. If that's a skill that you're still struggling with, then you're going to face a tougher challenge, but it's still doable. You're probably just going to take a couple more minutes to figure it out, but it's all good. So here, 100 divided by 4, that's 25. And then 8 divided by 4 is going to be 2. And that's as much as we can reduce. The reason I know that is because 2 and 25, the only factor they share now is 1. And dividing this by 1 and dividing this by 1 is not going to change the value of the expression. So we're done here. So x is going to equal 25 over 2. Now before I show you another example, let's say you didn't get the greatest common factor. So let me just do some side work here. So side work. So let's say you were able to spot that 2 divides both of these numbers. So here you could have done division by 2 for both numerator and denominator. And here you would have been able to figure out that 100 divided by 2 is 50 and 8 divided by 2 is 4. But now once you get to this part here, you're going to be like, hey, there's still something, we can still reduce this fraction. If we divide the numerator by 2 and the denominator by 2, that's fair game. So we can do it again. And then we would get 25 over 2. And then after this, we would realize that these two numbers don't share any other factors besides 1. And that's indicating to us that we've reduced this fraction. So again, if you're able to spot the GCF immediately, more power to you. If you can't, then do it by parts until you can't reduce no longer. And this is probably the technique that people who are still struggling with their multiplications and divisions should approach. Well, let's take a look at one final example. Example 6. Now here we have more algebra, so this is more fun. So we gotta solve for x. Well, and before I split this, I'm gonna do my cross multiplication since I have a proportion. I have a proportion because I have one ratio equaling another. So here I'm going to multiply x minus 3 times 10. And in your problems, they don't always specify the parentheses. Okay, so you just got to be careful. Just always put them just to be safe. So here you have x minus 3 times 10. And then we have x times 9, which is, well, we got x times 9. Now let's go ahead and do the splitting here. Here on the left hand side, we're going to have to apply the distribution. So 10 is going to distribute to the 3 and to the x. So 10 times x is 10x minus 10 times 3, which is 30. And then x times 9, we're going to get 9x. We got to isolate the x's. Here we have x's on the left, we have x's on the right. We're going to have to make a choice, either move all of the x's to the left hand side or move all of the x's to the right hand side. Both of them are valid, but one technique that a lot of students follow, and I mean, I guess it's alright, always subtract the smaller one. So here 9 is smaller than 10, so we're going to get rid of 9, so let's get rid of 9. So minus 9x, minus 9x, 9x minus 9x, we're going to get 0. And then 10x minus 9x, that's just 1x. And then we still have that minus 30 here. And we want to isolate x. Well, we have a negative 30, so let's add by 30 to get rid of that. So if I do something on the left, I have to do it on the right. So negative 30 plus 30, that's going to give us 0. And then 1 times x, that's just x. So we get x plus 0 equal to 30. And x plus 0 is x. So here we get an integer solution. So x equals 30. And that's it. So try the proportion problems. And just to reiterate, here if we would have subtracted the 10x, I promise you we would have gotten the same thing. So that's something I encourage you to do. So here, bonus question. Whoa. Well, you're not going to get bonus points, but this is I should call it extra practice. So for extra practice, verify that subtracting 10x will lead you to the same answer. Alright, I'll see you in the next lesson.